All right. So the examples you just seen were some pretty cool stuff. Speech to text, detecting text and images, facial recognition, emotions, etc. But you can also use your other FileMaker data for things like classification or deriving insights via clustering. And the difference between clustering and classification is similar to what you've seen, and it's building a model like Johan talked about, and training it. And then clustering is discovering unknown structure. And so I'm going to present a few problems just to show the difference between classification and clustering. And I've tried almost all the tools on the slide I showed of tools. And what I came up with for this session was some very simple low-hanging fruit kind of tools that are easily accessible for FileMaker and ABI integration. And so we're going to use these tools. And you might have never heard of some of them, and you might have heard of some. So the first problem we're going to talk about is classification, where we have a client with this situation that has, they buy a bunch of surplus, they get in a bunch of products, they can text extract what these product names are, but then they need to classify them to sell them online. So what I found to use was this monkey-learn retail classifier that does text classification, and it can do this on the product names. So a little bit about monkey-learn is they have a bunch of pre-built services. They do a lot of sentiment and tone detection as well. They also have a bunch of extraction surfaces for text extraction. And the one we're going to look at is the retail classifier. And you can try it out with some text, see how it classifies. This is a pre-built service, try it in batch. And then the API information is here with a model ID, and then you're going to get JSON back, so it's easy for FileMaker. So if we go to our problem, this is just a simple FileMaker layout, and I have a button to call the retail classifier. I'm just going to do this singly as opposed to in batch. So let's take a quick look at the script. And it's a basic calling an API call. I'm going to set up my request JSON. I'm going to call that specific model ID in my post. I'm going to send it my product name, my API key. And then I'm going to execute the query, parse the JSON into variables, and then I'm going to set my field, the tag name being the category. So I set this up with Geist Generator. It was, to start with, it was pretty simple. To tweak the, so then when I go out and call this classifier, this retail classifier, note that it doesn't have a lot of text in the product name. So it has minimal text it can classify with. And then it's bringing things back like cell phones for Bluetooth headset, that's okay. Party occasions for envelopes, home for clock. It's classifying across a wider retail as opposed to specific to my office supply and office furniture company. So that brings us to the kind of the second classification problem is I want to categorize these product names text, but the pre-trained service is not specific enough to my use case. And monkey-learn has a very simple way to build a custom model specific to my data. So this screenshot shows kind of their build screen where I've pulled in my product name, all my product names, I think there were 9,000. And then what I'm going to do is I'm going to train or tag the data. I'm going to label the data. So I started out with 5 categories here: furniture, furniture accessories, technology, technology accessories. And it wants me to train 20 texts because it wants a minimum of 4 texts per category. And at some point here, I'm going to add another category for storage mechanisms, and it's going to ask me to tag 24 texts. Now at the top, those in the back probably can't see, but it says it's going to start learning from my criteria. So right now, as we speed it up here, it's kind of guessing. It's not guessing quite correctly. I'm still training it myself what the correct categories are for my text. And around text 20, which is not very many texts, it starts discovering correctly the technology accessories, the furniture accessories. And then I can name my model. So now I have my own custom model. And I can try it out in the same ways that we showed with the retail classifier. I can try it out with some text. it gives me an API with a new model ID there, and there are my tags. So now I have a custom classifier, and I'm going to use the second button to classify, and it's going to call the exact same script with just a different model ID. Oops. Let me call that, sorry. So now when the confidence score is going up a little bit, and it's really categorizing quite well with the minimal effort to build a custom classifier. So you saw a pre-trained service, where you just make the API call up and it sends your text. And then you saw me build a custom classifier to classify my product name text. So those are two examples of classification with basic product name data in FileMaker. So the other type of problem is clustering, where you have customers and you have data like sales and profit and discount, and you want to understand which customers are similar by these variables, and there's no pre-trained service or custom service out there that's going to allow you to do this. So that's where we get into clustering. So what is clustering? Well, there's a good explanation on the slide, and then the images show a classic machine learning example from a Stanford class where a company has height and weight data, and they need to discern 4 shirt sizes from that height and weight data that correspond to that. They can't make 100 shirt sizes. So they use clustering to discern the 4 shirt sizes, and they group them into colors in the image below. So this clustering works most well on multiple attributes, and it's for situations where you can't easily discern by looking at it. You can use your gut, or you can try to finagle a report. But if you use clustering on data and statistics, it's more valid. So what are some other business impacts of clustering? Well, Luke and Johan showed the tone analyzer, where they were analyzing employee tone and how anxious they were talking to a chatbot. But that's a little big brother. So if we think about customer tone and how that can help, if we analyze customer tone and got whether they were negative, et cetera, say we had 1,000 customers, we could then cluster the customers into groups of unhappy, neutral, and happy, so that we can give some oversight to the unhappy group. So if you, the audience, were customers, and I knew which ones of you were unhappy, and I had your seat ID, I could go out and give you a ticket to our chocolate party on Wednesday in room 7123 at 5:30 p.m. and make you happy. So there's value in knowing who to give oversight to. There's also value in knowing who to market to. And there's a great example of this from back in the 90s. Way back in the 90s, Bank of America used clustering, the same algorithm, to cluster customers. And they found out that there was a cluster that had a high propensity for home equity loans. They were all middle-aged, married with teenage children, and 30% of them had personal and business-oriented banking problems, meaning they were small business owners. So Bank of America started a campaign targeting home equity loans to that demographic to start a small business, and it had a lot of success. It seems kind of intuitive these days, but it wasn't back then, and it was a big success for them. So I want to talk a little bit about the clustering algorithm that we're going to look at. It's called K-means, and there's a reason we're looking at this one. Just a little bit about how it works is that it splits the data into K clusters. That's part of the K-means name. And then each cluster has a centroid that corresponds to the mean value for the members in the segment. So that's where it gets the name K-means. So the algorithm then places the centroids so that the total sum of the distances between centroids and members in respective segments is as small as possible. And I have a short little cartoon that shows how it iterates. And remember that when you have multiple attributes, it's very hard to do this visually and get real statistically valid clusters. The reason we're talking about this particular clustering algorithm is because it's a low-hanging fruit for FileMaker, because FileMaker integrates well with Tableau, and Tableau actually has built-in clustering in it, okay? So you can visualize in Tableau, Tableau being a visualization and data prep tool if you're not familiar with it, And then you can use the built-in clustering, and you can even write the results back to FileMaker via the Data API or SQL. Now, another thing you can do that's not as low-hanging is you can call Python from Tableau or even FileMaker. And Python, if anyone doesn't know, is one of the most popular machine learning languages. There's a lot of frameworks for machine learning in Python. And if you don't know Python, you can easily hire a Python developer to do what you need to do to integrate here. So let's get back to our problem. So here we are in Tableau. We have sales and profit for our customers and discount and quantity sold. And so how do I cluster this? I simply go to the Analytics tab of Tableau, and I pull over the cluster, and it clusters it. Then I can look at how it's clustering it, and there's some interesting things if you watch the video later about the clustering and the discounts and where the profits are. And then I can also pull the cluster result over to use as a dimension. I can show it on a map or do things like that, but I can also look inside the group here, and I can see the customers it relates to. So pretty low-hanging fruit. The other thing I can do, and we're going to show the same algorithm, the same k-means algorithm, is I can set up this TabPy server, which integrates Tableau and Python. So it allows you to call Tableau from Python. So how you set it up is pretty straightforward. And then I can start the TabPy server. And then in Tableau, I'm simply going to set up an external service connection to port 9004. And I can now call the run Python from Tableau. So we're going to look at a different problem here just because it's fun to visualize on a map. But we're going to use the same algorithm, k-means. So this problem is I want to find similar states that have a total customers and quantity sold. So I'm going to cluster the similar states, and I've put total customers and quantity sold here. And that might be for marketing purposes or placing salespeople, a number of reasons. So what I'm going to do is I'm going to deploy, this is a simple Python k-means function just with two variables. I'm going to deploy this onto my TabPy server. And this is just a Jupyter notebook where I'm running through, there's the function, and then I'm deploying it onto my TabPy server. And I'll show you here where I've deployed it onto the TabPy server. And then in Tableau, I just make a calculated field where I call the k-means cluster, I send it the quantity and customer count, and it calls the function when I add it to the Tableau sheet, and now I have my states clustered by similar ones, and it's by label and color here. The other thing I can do is I can call Python. I'm using the David Haman's Data API wrapper for Python, and I created a calculated field here that I'm going to use to write my cluster results, the cluster number and the state, back to FileMaker so that I can use it for marketing or salesperson placement. So take a look. So here's my call to the server. I'm sending it the state and the cluster number, and then I'm sending it back to a temporary table, and I can use it in FileMaker. So that you can try this out, easily get started with this, I have demo files. And another thing to note is that Tableau also has other machine learning integrations like Data Robot. They also integrate with AWS. They'll probably, now that Salesforce owns them, Salesforce has a lot of machine learning. They'll be integrating with that. So there's a lot of different machine learning integrations you can do with Tableau and then field back to FileMaker. And then I also provided the classification demo as part of that. And then I want you to be happy, so come to the chocolate party. And we'll be available in this room for the next 30 minutes. We'll have updates to our sessions. And then I have additional slides and resources with some learning areas. So thank you. All right, so any questions?
Tell them to ask the question until they get a mic.
Oh, ask a question when you get a mic, yeah. Yeah, so if you have a question, let's bring you a mic, so, yeah, yeah. Okay, what's your question? Well, we need a mic. Yeah.
Hey, is this on?
So, hello.
Hello.
So thank you all of you for a wonderful session, very, very illuminating. I had a question. You were mentioning Python as a tool, and I was some people also talk of the tool called R, and I was wondering if you could comment on that.
Yeah, so actually one of my slides I showed the integration to, let's see, I only have Python here, but Tableau, you can also set up that same external service connection to R. So you can, well, I think what I've read is that Python is more the direction that, that people are going there, but yeah. But yes, you can call R from Tableau as well, yeah.
Yes, I have a question on the integration between FileMaker and directly to Python without going through any of the services, to use PyTorch or to use TensorFlow without going through Tableau. How did you do that?
Well, I think you could use the Python data API wrapper to do that. I actually played around with TensorFlow a little bit from Tableau and was able to make it work, so you could do that with FileMaker.
Without Tableau?
Huh?
I mean, Tableau is not necessary then?
Not necessary, yeah, no, and I think on one of the slides I show you can use Python directly from FileMaker.
You have
yeah.
the data API now,
Yeah.
so
Yeah.
that API you can just open up and
Yeah.
you can ask any kind of question to that like any other one would do. So that API is just up to you to set a structured data and then you
Yeah.
can call it up.
Yeah. Oh,
Okay, so question here is that to get data back and forward. So yeah, as long as you're storing that data in a place where you can interact with, you can always do a call that way too.
yeah.
I think we have time for one more question.
Well, we'll be around for a while.
Would it be possible to use the AI and machine learning completely privately, not sending anything out to any other service? Could I have it all installed on my own server and send nothing out to the cloud?
So if you don't have any connection right now, then most of the AI that exists right now, they are service-based. So if you want to have a local one, you can always go the way Luke did and invent your own chatbot, but it's a little bit tricky, so a few things to fall on.
Right, well, I mean, if you use Python library, you know, you can, if it's only code as opposed to going out to the cloud, you can, yeah.
So the other thing I did too was, so I built the chatbot inside of FileMaker, one of those can I do it kind of things. But the other thing I did was I did Tara recursive multi-dimensional fractal derivative algorithms using custom functions. So by many people's standards, that's machine learning. And the way it works is because I broke down statistical formulas like to their basic parameters. So if you started using my program, it could all be run local on a phone for that matter, really. If you keep using it just through natural statistics, the variability, because if you do what it tells you to do and you start to behave in the way it's predicting that you should behave, then the variability of your behavior goes down. So then statistically the standard deviation goes down. So then all of the parameters that we're feeding my algorithms modified themselves without anybody touching them, purely based on the behavior of the people that were using the app. So I spoke to one of the guys at Unilever. I never used to call it machine learning, and he broke it apart with me. He said, "Why aren't you calling this machine learning?" And as Heidi had that slide where she showed AI, machine learning, and deep learning. Luckily for me, he was right. I was doing machine learning, but I wasn't doing deep learning. So the neural networks, it didn't have a neural network in it. I was like, oh, it's not really machine learning then if it doesn't have a neural network. But he was saying, no, like that's still machine learning. But the neural network is like really deep stuff, and that's where like you're winning games of Go and all that kind of thing. So I think you can absolutely, like in our talk last year, I don't know if you went to that, but okay, so there's that whole discussion about pure AI, where I sit there with engineers and debate about whether something is artificially intelligent or not, and you use Turing tests to modify it and all that. So if you can move away from the pure definitions of it, what I just cannot believe about this product we all use is how much I can do on a tiny little FileMaker Go app, like custom functions, tail recursive. It's just so much fun. I was one of those things, how far can I go before I get outside of FileMaker? I'm sure I'm not the only one here that does that. Like, how far can I push this? And there was an application for, I don't know if Bonnie still here, she might have left now. So Bonnie's doing this amazing thing with a robot that is artificially intelligent robot, like a real robot now, not one in the cloud. We've got half an hour, so I don't think it matters if we go on a little bit.
Yeah.
Does anyone, should I keep going?
Yeah.
So there's this real robot that's got
mine.
AI in it, and she uses it to teach kids with autism.
Yeah.
Thanks. So this robot talks to kids with autism. It's really good at training them. And she said exactly the same thing. She said sometimes in a classroom they can't get to the cloud. And she asked Jan and I, is there something you can do so that it can be like a cut down version of the chatbot? So like just something so it doesn't just stop dead. So when it loses the internet connection or has a slow connection, what we could do is actually build something in FileMaker that's good enough to keep the conversation going until the internet connection's back up again. So I think there's a big yes to your thing, but if I say yes, there are plenty of people who will debate with me and say, well, that's not really machine learning. So we'll have that over a beer.
Perfect. Thank you very much.
No problem.
So I'd like to congratulate all the presenters. It's a great topic, and I think it's going to influence all of our lives going forward. So congratulations, guys. But I do have a question. Is AWS going to become the next Skynet?
So Heidi will give that one to you. Heidi will answer that question for you.
We'll have to write a machine learning algorithm to predict whether that will happen based on. Right.
Just a very specific question. Is the facial recognition and voice recognition good enough to be used for username and password?
So, yeah, definitely. There is, once you connect up, you have a specific account. So you'll be able to send just your data, and it's a secure transmission of your data. So I think we could say that it is. Yeah, like if you come to our session tomorrow, I'll tell you a little bit more about how you can use that recognition service to actually use as a monitor to get into a building or whatever you need. Just show your face or talk to a monitor, and that will open up the door or whatever it might need it. So I'll give you some more details tomorrow. Yeah.
Anyone
You already
else?
have your phone, the new iPhone X. They look in your eyes and then they open up.
So they're using facial recognition. iPhone's using that now, right?
I was thinking more with a web camera. Phone or web camera.
Yeah, you are the one responsible of taking care of the result that comes back from that service. And then whatever comes back that's suited for your solution is just the thing you need. Yeah, more
Anyone
questions?
else? No? Okay. We'll be around, all of us. Yeah.
Thank you, guys.